Okay. So just let's see again. EM waves or electromagnetic waves are first they were predicted by Maxwell. Presence of this was explained by Maxwell in contrast to the light. And later on, Hertz produced them in his well-known experiment, keeping the two metal conductors nearby and providing very high voltage. वहां पर spark हुआ. Spark is nothing but accelerating charges, and nearby he kept the what is called conductor. है ना, वहां पर जो है उसमें भी फिर nearby जब देखा, so there was again in the two tips of the conductor there was spark because of EM waves producing the electricity in the conductor. That's how he could predict, and also when he kept the conducting ring having some gap in the ultraviolet radiation, spark was increased. So he could predict the electromagnetic, he could predict the what is called photoelectric effect also simultaneously. He produced the EM waves simultaneously. He invented the photoelectric effect. He could get the effect, photoelectric effect in that experiment. Okay. Marconi was later on, he used this EM waves for his wireless communication. And EM waves, it is combination of electrical and magnetic fields oscillating in phase. मतलब एक साथ peak value पे पहुंचेंगे, एक साथ zero value पे touch करेंगे, and mutually perpendicular and propagating perpendicular to their oscillation. ठीक है, they are mutually perpendicular. Electric field इधर oscillate हो रही है उस समय, magnetic field इधर oscillate होगी, propagation इधर होगा. All three are mutually perpendicular, and they are produced, of course, by accelerating charges. So this is the oscillating of electrical and magnetic field and their propagation, EMS propagation. Now you see properties. I told you four properties generally you are required to write. First one, they are transverse. Transverse means oscillation is perpendicular to the direction of motion. Both the oscillation are perpendicular to the direction of propagation. They don't require medium for propagation. They can travel in vacuum also. And also direction of propagation is along E cross B. यहाँ पे देखिए at this moment E is this side, B is this side. So E cross B will be this side. Now E has come down. Put all the fingers up right hand in this direction. Palm should be facing this side. Again, thumb will be facing this side. So E cross B gives you the direction of propagation. Energy in EM wave is equally divided in electrical and magnetic field. Whatever energy is there, 50% will be in the electrical field and 50% will be the magnetic field. Both will contain equal energy content, half of the total energy at that moment. ठीक है? Electrical component of EM will produce the visible effect. Electrical will produce the visible effect only. Magnetic will not. It means whatever light we see, total energy in the EM waves at that moment is what is called twice of that. तो light है वो 50% से ही आ रही है ना, agreed? 50% से ही light आ रही है. Remaining 50% is in the magnetic wave, in the form of magnetic energy. ठीक है? And next one is the EM wave travels with the speed of light c in the medium such that ratio of magnitude of electric field to the magnitude of magnetic field at that moment will give you the speed of light. It can be, if we take the peak value, we have to take the peak value here also. If we take the other value, we have to take the corresponding magnetic field at that moment. सपोज हमने ई ये लिया ये वाला, तो बी भी फिर आपको कम वाला लेना पड़ेगा। If you take E this much, to B this much you have to take corresponding value of B. And also, if mu and E are the permeability and permittivity of medium, then the speed of light in the medium is given by this relation. 1 upon under root of product of both. And in vacuum, we will take absolute values. And the refractive index of medium is ratio of C by V. So we get this. This can also be written as relative values. All right. ठीक है यहाँ तक. And 8th one is electromagnetic wave, like other waves, carry energy and momentum. Since it carries momentum, an electromagnetic wave also exerts pressure called radiation pressure. If you use the energy transferred to the surface completely, then momentum delivered to the surface will be ratio of energy to the speed of light. Very small momentum. C is very large, 10 to the power 8, तो ऊपर जाके 10 to the power -8 हो जाएगा ना. So small momentum, very difficult to detect even. High intensity source can show you slight deflection in the objects. That should be kept on the frictionless surface, or they should be hanging, and then you focus the high intensity beam, then it can deflect slightly because small momentum is there. Got it? All the points clear? Can we solve this question now? Which formula we are going to use? Plane electromagnetic wave of frequency this much, 25 Hz, travels in free space along the x direction. At a particular point in the space and time, electric field vector is given by this value. What is magnetic field vector at that point? वेक्टर फॉर्म में लिखना. पहले मैग्नीट्यूड निकाल लीजिए, फिर वेक्टर फॉर्म में लिख दीजिए. मैग्नीट्यूड कितना होगा? कौन से फॉर्मूले से आएगा? Are you there or not?
Yes, sir.
Okay. It is coming to be 2.1. Unit will be, ऐसा यूनिट में लिखना है टेस्ला. वेक्टर फॉर्म में यहाँ पे क्या लिखे? आई कैप, जे कैप, के कैप और माइनस आई कैप माइनस जे कैप माइनस. डायरेक्शन बताइए. Which one? K cap. Okay. It is going along the x direction. Electric field at that moment is j cap है ना, along y. So at that moment it should be along z axis. तभी तो E cross मतलब J cross K cap. Will be equal to I cap, which is this side. They are given going along the positive x direction. All three are mutually perpendicular. ये I हो गया इसका और इसका J हो गया, तो ये K cap बचेगा. But you have to see whether it is positive or negative at that moment. Got it? 50% तो आ जाता है. एक I है, दूसरा J है, तो तीसरा K हो गई. But only thing, whether it is up or down, whether along the positive K cap or negative K cap, that will be given by right hand rule. All right, no problem here. Vibrations, what will be its frequency of B? B की frequency क्या होगी? B किस frequency से oscillate करेगा? Hmm? 25 megahertz. Frequency will remain same. Both are in phase. जितनी oscillation electric field करेगी, उतनी ही magnetic field करेगी. So both will have same frequency. Got it? It's given. It's given. Let's see further. ये question कैसे करेंगे बोलो? How to do this question? Short example. How to get the wavelength and frequency? If equation is given and electric field का भी equation बनानी है. How to get the wavelength बोलिए? Equation of wave लिखते पहले. Equation of wave can be written as like this. Y okay, y लिख दो लड़. kx पहले लिख सकते हैं, ओमेगा t पहले लिख सकते हैं. Doesn't matter. Both can be written first. So x का coefficient k है. Can you see here? So this is k. K is 0.5 into 10 to the power 3. ठीक है. K is called propagation constant, if you remember, which is equal to 2 pi by lambda. ठीक है. इसको हम 2 pi by lambda लिख के सॉल्व कर सकते हैं. Lambda will be 2 pi upon 0.5 into 10 to the power 3. जो भी आएगा मीटर में लिख देंगे. इसको सब ऐसे यूनिट में दिया है. ठीक है. ऐसे ही t का कोएफिशिएंट ओमेगा होता है. the whole thing will be omega, और ओमेगा क्या होता है 2 पाई न्यू, न्यू मिल जाएगा, फ्रीक्वेंसी मिल जाएगी, ओमेगा एस 2 पाई एफ 2 पाई न्यू। हम लोग फ्रीक्वेंसी का सिंबल एफ यूज करते आ रहे हैं, तो वी कैन यूज एफ और न्यू जो भी है, तो फ्रीक्वेंसी भी मिल जाएगी। राइट एक्सप्रेशन फॉर द इलेक्ट्रिक फील्ड, इलेक्ट्रिक फील्ड का एक्सप्रेशन देखो, ये एक्स क्या इंडिकेट कर रहा है, इट इज गोइंग अलोंग द एक्स एक्सिस। वाई क्या इंडिकेट कर रहा है, इट इज ऑसिलेटिंग अबाउट वाई एक्सिस। तो मैग्नेटिक फील्ड विल ऑसिलेट अबाउट जेड एक्सिस, तो लेकिन उसका जो है पीक वैल्यू चाहिए, तो ये मैग्नेटिक फील्ड की पीक वैल्यू है। दिस वन इज बी नॉट, वी नो सी इज इक्वल टू बी नॉट अपॉन, नहीं ये ई है, हाँ ये सॉरी, ये आपकी बी मैग्नेटिक फील्ड है, इलेक्ट्रिक फील्ड क्या फार्मूला है, ई बाई बी। Yes, we can use it. बी की वैल्यू तो कुछ छोटी आती है ना, इफ यू सी बी इज इक्वल टू ई बाई सी, सी जब डिनोमिनेटर में होगा तभी बी विल बी वेरी स्मॉल, 10 to the power minus, you can see this much. तो then वैसे भी याद कर लो, if you cross multiply c and b वाले टर्म से एक साथ आ जाएंगे, e is equal to c into b, तो just develop your technique to remember this। तो हमें क्या चाहिए, e चाहिए ना, इलेक्ट्रिक फील्ड की इक्वेशन लिखनी है, ई नॉट चाहिए, बी नॉट इज गिवन, बी नॉट क्या ये है, हाउ मच इट इज कमिंग 0.6, तो वो यहाँ पर आ जाएगा। नाउ sorry, now you see how to write the equation, electric field is vibrating along the z axis, यहाँ पे Ez लिख दीजिए, एंड होल थिंग ये पूरा एज इट, ये वाला टर्म रिप्लेस कर देंगे ई नॉट से, रिमेनिंग होल थिंग विल बी एज इट इज, उसमें कोई चेंज नहीं करना है, बट यूनिट चेंज हो जाएगा यहाँ पर, इलेक्ट्रिक फील्ड का न्यूटन पर कूलम, ई नॉट कितना आ गया 0.6, दैट्स ऑल, तो दैट्स ऑल। इन विच डायरेक्शन वेव इज गोइंग, यहाँ पे देखो प्लस है, प्लस और यहाँ पे एक्स है, जब प्लस होता है तो नेगेटिव एक्स की तरफ जाती है, इस तरफ जा रही, it is going toward the negative x-axis। ये थोड़ा सा 11th का पार्ट है, they may not ask this question, but still it is given in our textbook, so we are supposed to know। They may ask part of the question, like if they give you the equation, they may ask find out the what is called peak value of electric field, this much we should know, this much, this we should know, this is the amplitude, मैग्नेटिक फील्ड का एम्पलीट्यूड दिया है, तो इलेक्ट्रिक फील्ड का एम्पलीट्यूड मिल जाएगा हमें. दिस रिलेशन इज वेरी मच important. Getting or not? Anything you want to ask here? इसमें कुछ पूछना है आपको, बोलिए. Are you there?
Yes.
Yes, sir.
Anything you want to clarify here? No problem.
But the amplitude 60 होना.
10 to the अच्छा ये माइनस है, सॉरी यहाँ पे माइनस है तो 10 बचेगा ना. -7 I thought. But generally these value also remain. ठीक है, 60 is not big value as far as electric field is concerned. Magnetic field की value बहुत low रहती. In terms of Tesla, it is very low value. Thank you. Okay, anything else here? Correction you can tell immediately. Don't wait for that. My asking can be mistake होती है because it will be. You will be others may think ये कैसे है. It should be corrected immediately. It saves the time. All right. Okay. Now, what is the spectrum of EM waves? Spectrum means arranging them in the increasing order of frequency. तो frequency के increasing order में arrange कर लो. तो सबसे at the bottom radio waves will come. Then microwaves have further higher frequency, higher energy. Then infrared. Next is visible. Ultraviolet have got more frequency than visible. X-rays further more, gamma further more. If we go on the top, frequency goes up, wavelength goes down, and the wavelength are reciprocal of frequency. So spectrum means arranging them in sequence in increasing order of frequency. So you should remember this sequence. Top में क्या है? Gamma है, high frequency, high energy. Then this is the sequence. Going down means frequency goes down. And uses also we should know. ये आपका NCERT बुक का डायग्राम है, थोड़ा सा ओवरलैपिंग भी रहती है कुछ पार्ट में. देखें, यू कैन सी करस्पॉन्डिंग यहाँ से यहाँ तक का जो फ्रीक्वेंसी है दैट कम्स इन द गामा रेंज एंड वेवलेंथ आल्सो. एंड लोएस्ट में देखो इधर रेडियो वेव्स है, उनको उन्होंने दो पार्ट में डिवाइड किया हुआ है. शॉर्ट रेडियो वेव, लॉन्ग रेडियो वेव. लॉन्ग मीन्स वेवलेंथ फर्दर मोर, फ्रीक्वेंसी फर्दर लेस. So these are the radio waves. Visible को उन्होंने explain किया. Visible is ranging from 400 nanometer, which will be corresponding to violet, up to the 700 something plus nanometer that will be red. यहाँ पे इंडिगो भी आएगा बीच में. Okay. Arrange the following in increasing order of the wavelength: infrared, gamma, radio, अल्ट्रावायलेट पे. सबसे पहले क्या आएगा बोलो? इंक्रीजिंग ऑर्डर में लिखना है.
Gamma ray.
लीस्ट वन गामा, उसके बाद नेक्स्ट वन विल बी ultraviolet, then infra, then radio. ठीक है. Increasing order में least one first. So gamma have got more frequency, least lambda. Applications are generally asked. Applications are also asked most of the time. Uses. Radio waves are used in radio, TV, cell phone. Okay. Microwaves are used where? They are used in the radar, microwave on, satellites, speed gun, etc. एयरपोर्ट पे जो रडार घूमते रहते हैं ना, एयरपोर्ट पे एरोप्लेन को लोकेशन फाइंड आउट करने के लिए they use the microwave. Microwave satellite phones are there. Military and intelligence people, they use the satellite based cell phone, which can be directly connected to any part of the world, depending upon that receivers placed there. So microwave, infrared, also called heat waves, they are used in remote control. They are invisible, है ना? इसलिए remote control में invisible use करते हैं, because if you use the visible, then it will be irritating, and then again and again light will be produced. It should not be visible, and same time job should be done. So less energy वाली wave use कर सकते हैं. Remote में physiotherapy, because they are producing heat also, heating effect also. To look through the fogs and haze, they can penetrate the foggy weather. Infrared are used, and infrared cameras also, night vision cameras भी use करते हैं. They use the infrared radiation, and they play a role in the greenhouse effect, which keeps the earth warm after the sunset. Sunset के बाद earth gets heated up. It emits the infrared radiation. So जो greenhouse gases हैं, they will send it back to the earth during the night time. Otherwise, temperature will be in minus after the sunset. Temperature everywhere will touch to the minus 18 degrees Celsius, including Nagpur. So they are taking part in the greenhouse effect, which has its own advantage and disadvantage. Advantage क्या है? Night के time में it keeps the earth warmer. Otherwise, everything will freeze everywhere. And also, concentration of greenhouse gases like CO2 and methane and chlorofluoro, that gases, their concentration is in increasing. Therefore, the earth is becoming more and more warmer. Average temperature is going up every decade, and that there is the risk of melting all the polar ice. But that is a disadvantage, and it has advantage also. Visible also, we can use the human either can see through the visible light only. Ultraviolet, UV, they are used to kill the germs and bacteria in the water. They are used in the packaging industry for the same reason, killing the germs and bacteria before packaging the eatables and other things. For same reason, they are used in the to sterilize the surgical instruments. Ultraviolet rays से surgical instruments can be sterilized and used in the LASIK laser for eye surgery. Many uses, many useful uses. है ना? Medical industries also. Got it? X-rays are there. X-rays and gamma rays, they are high frequency, high energy radiation, therefore used for treatment of certain forms of cancers. High energy radiation can be focused on the cancerous cell and that can be killed. For crack detection in the bones and metals and other medical sciences. Gamma is also used to destroy the cancer cells. And gamma are produced. How they are produced? Gamma rays. Do you remember? Gamma rays कैसे produce करते हैं? In fact, they are produced in the nuclear reactions. है ना? When it is followed by alpha and beta radiation, when the nucleus goes to the higher energy state, when it comes back to the ground state, there is the one or more photons of gamma radiation every time. So nuclear reactions may produce the gamma radiation, which is the electromagnetic waves. Other two are the particles. That photoelectric effect may alpha and beta were the particles, but gamma is the EM waves. Okay. Uses are important. Sometimes question comes, identify the wave, EM waves and write it uses. Identification के लिए आपको थोड़ा सा आइडिया होना चाहिए wavelength का. So let's see the next table in which identification can also be done and how they are produced and what are the uses. So they ask the question from this table also sometimes. जैसे microwave, they will give you the wavelength की range इतना है 0.1 meter, that is 10 centimeter and to 1 mm, 1 mm to 10 centimeter. How they are produced? Using the magneton valve or this valve, and detection, point contact diodes से detect कर सकते हैं. So difficult to remember whole table, but then also you have to go through some of the like X-rays they ask. कितने X-rays का 1 nanometer to 10 power minus 3 nanometer. They are used in the X-ray. They are produced in the X-ray tube. Detection also you can see this. So ये थोड़ा सा table you cannot neglect this table. They have started asking from this table also some of the questions. Okay. So next one is the displacement current. Up to here is there. यही तक ही है. This displacement current they have just removed, but examination point of view, JE point of view we can see it. तो जैसे हमने देखा AC जो है, it can cross the alternating current can cross the gap between the two plates of the capacitor. Gap is there, insulation is there. How can it cross? So it is because changing nature of electric flux can produce the induced current between the gap. According to Maxwell, when capacitor is charged or discharged, then due to changing electric flux, यहाँ पे चार्ज पाइल अप हो जाएंगे तो फ्लक्स भी बढ़ जाएगा, इंक्रीज होगा, या फिर चार्ज कम हो जाते हैं, जीरो होके नेगेटिव हो सकते हैं नेक्स्ट साइकिल में, फिर डिक्रीज होगा, तो इलेक्ट्रिक फ्लक्स विल आल्सो डिक्रीज इन द गैप. Therefore, changing electric flux between the two plates of capacitor current is induced in the gap called displacement current. Flux का formula लिखा E dot A, cos 0 will be 1. Electric field लिखा capacitor plates की, sigma is charge upon area, area cancel हो गया, तो ये आ गया Gauss's law जैसा कुछ आ गया, flux is 1 upon epsilon naught times into the charge in cross. क्रॉस मल्टीप्लाई किया, डिफरेंशिएट कर दिया उसको, रेट ऑफ चेंज ऑफ चार्ज इज कॉल्ड करंट, dq by dt. ये कांस्टेंट है तो इसको डिफरेंशिएट करेंगे. इलेक्ट्रिक फ्लक्स अगर वेरिएबल है तो डिस्प्लेसमेंट करंट होगा, नहीं तो नहीं होगा. And in case of alternating current, whatever the RMS current is there, same will be the displacement current. सीरीज में है ये, यहाँ से जो RMS करंट जा रहा है, बीच में डिस्प्लेसमेंट करंट बनेगा थोड़ी देर के लिए, बस both will be equal. They can competitive examination, they can confuse you. AC के क्वेश्चन में डिस्प्लेसमेंट करंट पूछ सकते हैं. Find out the RMS current. Same will be at that moment. Same will be the displacement current between the gap according to Kirchhoff law है ना. क्लोज लूप में करंट तो फिर वही रहेगा जो आरएमएस करंट है, वो उतना ही डिस्प्लेसमेंट करंट रहेगा. फिर से दूसरी तरफ यहाँ पर आ जाएंगे तो आरएमएस करंट हो जाएगा. ठीक है, आरएमएस करंट निकालने का हमने फॉर्मूला सीखा था, अप्लाइड वोल्टेज आरएमएस वोल्टेज अपॉन इम्पीडेंस जेड. ठीक है, तो दिस कैन बी यूजफुल फॉर your competitive examination only. Other part is useful for your boards examination. ठीक, ये भी एक्स्ट्रा में ही देख लो. फोर्स का जो है, if power of EMF is given, फोर्स निकाल सकते हैं, हमने पढ़ा था 11th में फॉर्मूला, और इज इक्वल टू फोर्स इनटू वेलोसिटी. तो वेलोसिटी की जगह यहाँ पे c आ जाएगा, स्पीड ऑफ लाइट आ जाएगा. F will be power upon c, और completely absorbing surface. बाउंस बैक हो गई तो 2 times of power upon c, डबल हो जाता है फोर्स एंड मोमेंटम दोनों. P by C and 2P by C. ठीक है, this can be useful for your competitive examination. इंटेंसिटी देख सकते हैं यहाँ पर. इंटेंसिटी क्या है? एनर्जी पर यूनिट टाइम पर यूनिट एरिया. इंटेंसिटी ऑफ द लाइट फॉलिंग ऑन द सरफेस पर यूनिट टाइम पर यूनिट एरिया. तो एनर्जी अपन टाइम इज नथिंग बट U by T, that is nothing but E by T लिख सकते हैं. U by T, that is nothing but power up, nothing but a power upon area. Intensity को power upon area we can write. तो रेडिएशन प्रेशर, अभी हमने फोर्स का फार्मूला ऊपर डिराइव किया था P by C. Pressure is equal to force upon area. So power upon C upon area. So power upon area is intensity. So intensity by C is called radiation pressure. अगर इंटेंसिटी दी है आपको उसको C से डिवाइड कर दो. Pressure again I told you C is the large value. Pressure will be very small. So it is difficult to notice. You have to have high intensity source of light. Then only you can see the pressure application and deflection of the object. Object should be very light in that case. If you want to deflect it with the light source. अगर उसने completely absorb किया तो ये formula, completely reflect कर दिया तो pressure will be double. So use the highly reflecting surfaces. If you want to see the deflection, if you want to see the effect of the pressure, light का pressure अगर monitor करना है, तो very intense source and reflecting होना चाहिए. Then only pressure can be significant, and that can be causing the deflection of the object. Pressure means force also. Force upon area that can apply more pressure means more force. Okay. So radiation pressure can be calculated by these formulas: intensity divided by the speed of light, and if it is completely reflecting, so it will be 2 times. Momentum डबल हो जाता है. मोमेंटम डबल हुआ तो फोर्स डबल हो गया, फोर्स डबल हो गया तो प्रेशर डबल हो गया. Got it? That's all. Tomorrow we may start the optics का देखेंगे ना. Mirrors we can leave it because they are just not in the that deleted part. थोड़ा सा उसको देख लेंगे mirrors को. Just law of reflection you are supposed to know, and then we'll see the reflection phenomena, that TIR and all, law of reflection through the cursor and all. That's all. All right.